Today we'll discuss about the classification of metal and alloys. When you discuss about the classification of metal and alloys, before to doing this, we have to ideas of engineering materials and their classifications. What are their classification of engineering materials? The first of all, we have to know on what is engineering materials. So, what is engineering materials is the big questions in around us. So, engineering materials is the main substance. Is a substance, first of all, is a substance. It's a substance which are useful in the field of engineering. In the field of engineering are called engineering materials. So this is the first point. Now, a particular material is basically selected on the basis of some following considerations. So, what are those properties that can you select and a particular material on a particular applications? So, first of all, it's properties of material. Now, properties of material basically that can be mechanical properties as we discussed in previous class. There's a physical properties, there's a chemical properties. So these are the properties that can select on the basis of your requirement on the properties. Some manufacturing properties, the mechanical properties, like that strength, on the basis of strength, ductility. You already some idea about this type of terms, which we will discuss on in the class, and toughness. So these are the mechanical properties. Now physical properties in terms of density, specific heat, thermal expansion. So these are the physical properties that can divide on a particular material to material, and chemical properties, that the oxidation and so corrosion is very much important property on a particular type of material. Is a corrosion effect or not? So basically the chemical properties. And manufacturing properties like formed or casting or machining or welding. So these are the points that can you discuss or that can you select on a particular following consideration under of properties of materials. What should be the properties? Is mechanical properties like strength, ductility, toughness. That can be physical properties like density, specific heat, thermal expansion. If you can discuss or if you can concentrate on particular properties like chemical properties. Chemical properties basically depend on oxidation, corrosion resistance, like these properties. Manufacturing properties also depend on basically is it formed or casting or machined or welding. So these are the different following considerations when you choose or when you select on a particular materials. Now this is the first point. So particular second point was cost of the material. So cost of the material. So cost of the material is one more important. So what should be the cost of the material in a normal way? So cost of the material, availability of the material in the market, availability of the material is very important consideration when you choose on a particular material in your particular location or particular applications. So availability is very much important. Now service in life of a material is also an important property when you choose a material. And one more interesting point is that appearance of material. Appearance of material in terms of color or surface texture. Surface texture. So what we discuss, first we discuss on what is engineering materials. So engineering materials is a substance which are useful in the field of engineering, that is called engineering materials. Now we'll discuss next what should be the properties, what should the following considerations, what should the considerations to choose a particular engineering material. First point was properties of material, second point was cost of the material, third point was availability of the material, availability of the material in the market actually. Now service in life of materials, because in service conditions, in life, in full life conditions, how much service they will give. And the appearance of the materials, appearance in the sense of color, in terms of surface textures. So these are the important properties that can select on a particular applications. So this is the important property. So this is the engineering materials. So basic idea, basic concept of engineering materials. Now we'll discuss on some mechanical properties. Some mechanical properties, like you know that what is strength, like this we already discussed on this particular topic on mechanical properties of material, like that. So we'll discuss on the class. That's the first important mechanical properties, like strength. Strength is nothing, is the ability of the material. Strength is nothing, is the ability of material is used, sorry, ability of material to resist, ability of material to resist the externally applied force. This is called strength. These are the mechanical properties of material. We already discussed on the class. So this is the basic review of the mechanical properties of material. You know that the stiffness also important property. Stiffness, elasticity, plasticity, ductility. So brittleness, malleability, toughness, resilience, creep, fatigue, hardness, these all types of actually mechanical properties, and then so on, mechanical properties of materials. Now we already discussed on this type of materials, mechanical properties of materials, strength, ductility, hardness, toughness. So already discussed on this. Now back to the main topic. So main topic is your classification of metals and alloys. We discussed on engineering materials in the previous lecture, in the previous topic. Now engineering materials, already discussed, is a substance which are useful in the field of engineering are called engineering materials. Now engineering materials can be divided into two categories: metallic and non-metallic materials. Now, metallic materials is such type of material where the metal will be present, and non-metallic materials means there is no present in the metal. So metallic materials can be broadly divided into two parts: the ferrous and non-ferrous type of material. Ferrous type of material is like that. Ferrous type of metal, or those metals which have the iron as the main constituents. So ferrous content is main constitutions in the metal. It's a ferrous metal. And non-ferrous metal means that is which have a metal other than the iron. That is called other than the iron. If any other type of metal will be present in the particular metal, that is called non-ferrous type of metal. Now ferrous type of metal can be subdivided into two categories: steel and cast iron. Steel is basically an alloy of ferrous and carbon we already discussed on the class. So alloy is basically mixture of two or more than element. This is called alloy. So steel is basically an alloy. Now alloy, if the carbon is only present in a particular steel, this is called plain carbon steel. And alloy steel is such type of steel. If you add ferrous and carbon, obviously they will be mixed together. But if you add some any other type of element like silicon, sulfur, phosphorus, titanium, vanadium, manganese, molybdenum, so this type of steel is called alloy steel. Now ferrous type of material can be divided to other categories like cast iron. Now, cast iron is such type of material where ferrous and carbon are mixed together, but the carbon percentage within the cast iron is greater than 2%. That is called cast iron. And cast iron can also divide into 3 or 4 divided parts, that the grey cast iron, white cast iron, malleable, and ductile cast iron. We will discuss on the later details. Now, non-ferrous type of materials. Non-ferrous type of materials, some example of non-ferrous type of materials. Because non-ferrous type of materials, non-ferrous type of metallic materials is basically metal type of material which have metal other than the iron, that is called other than the iron as a main constituent, like main constituent such as copper, aluminium, brass, tin, zinc, etc. So these are the non-ferrous type of metal. Now non-metallic material can be divided into two categories, organic and non-organic. Organic material is basically source of wastage of plant, wastage of any other type of building. So this is the organic material like plastic, wood, paper, rubber, leather, petroleum products. We already known to every day. So these are the organic type of material. And inorganic type of material is the main source of carbon compound. Carbon compound is basically exist in nature in the form of different types of material like mineral, glass, ceramic, graphite. So this is the inorganic type of material. Now, so this is the basic broad classification of engineering materials. When you discuss on a particular topic, first what you know about today's class. First is what is engineering materials. What should be the following considerations, like what should the following considerations that we'll discuss, properties of materials again. So the properties of material. So first of properties of material, next is cost of the material, this is the availability of the material in the market, the service in life of the material, and appearance of the materials. So these are the topics we already covered in today's class. Now we discuss on engineering materials broad classification. Metallic, non-metallic metal divided into ferrous and non-ferrous metal. Ferrous material can be divided into two, steel and cast iron. What is steel? What is cast iron? What are the different types of cast iron are present? We'll discuss on the details in the later. Now, non-ferrous type of material: aluminum, copper, magnesium, tin, zinc, lead, nickel, copper, alloy. So this is a non-ferrous type of material, and non-metallic materials are those type of materials where actually exist in organic, in the form of organic and inorganic nature. Now today we'll discuss on also ferrous alloy. So ferrous alloy is alloy which are those of which iron is the most prime constituent in ferrous alloy. We already discussed on this. It's a larger quantities than any other materials, any other metal. If the present, it is called ferrous alloy. And these are the main following factor that is that iron containing compound is the iron containing compounds exist because iron containing compound exist in abundant quantities within the earth crust. So this iron containing compound exist in abundant quantities of the crust, and metallic iron and steel alloy may have produced using relative economical extraction, defining, alloying, and fabrication technique. So ferrous alloy are externally versatile so that it have a wide range of mechanical and physical properties. Now we will discuss on steel. Steel are basically iron carbon alloy. Steel is basically and iron carbon alloy. So basically alloy of iron and carbon. So steel is your topic. Now steel is basically an alloy of iron and carbon with carbon content up to maximum of 2% in theoretically, but in practical cases the carbon percent actually mixed in basically up to 0.9 or 1% is maximum, because if you know that, if you know already that if the carbon percentage in a particular steel is increased, the strength will be increased, but as well as the ductility will be decreased. So this is the most dangerous cases. So in practical cases, maximum percentage of carbon that will mix together is a maximum 1% to 1.5%, but 1% is very much high. But in theoretically, steel is an alloy of iron and carbon, and when the carbon content up to maximum of 2%. Most of the steel produced nowadays is plain carbon steel or simple carbon steel. If the carbon percentage, we already discussed on that, the plain carbon steel or the plain carbon steel is basically steel where the only carbon component are present with ferrous, and then it's called plain carbon steel. And depending on the carbon condition, depending on the carbon content, steel is basically three types. So low carbon steel, medium carbon steel, and high carbon steel. So low carbon steel, there's a maximum percentage of carbon that is 0.30%. 0.30% of carbon, that is called low carbon steel. And in the low carbon steel, as the carbon content is very much low, so there is chances of obviously there is chances of low tensile strength and high percentage of ductility, and basically it is used in the products such as screw, nuts, nail nuts, bolt, tight and heavy structured members. So these are the applications of the low carbon steel. And second one is medium carbon steel, because this is the percentage depending on the carbon percentage. Now medium carbon steel is such type of steel where the carbon percentage basically from 0.30 to 0.60 percentage of carbon, where it is less ductile but harder and compared to the low carbon steel, and have tensile strength have greater than low carbon steel because of the carbon percentage increase in that particular type of steel, and they also have better machining qualities. So this is medium carbon steel. And what is the applications? Applications in the medium carbon steel is that making shafts, connecting rods, rails, axles, gears. So these are the applications of medium carbon steel. And high carbon steel means the carbon content is very much high, and basically in high carbon steel the carbon content is basically from 0.6 to 1.70% of carbon, and basically it's a carbon content is very much high, so that the higher tensile strength will be increased, and harder obviously compared to the plain carbon and medium carbon steel, and they are basically used as a hand tool such as wrenches, chisels, punches, files. So these are the applications. So depending on the carbon percentage, the steel is basically three types. First of all, low carbon steel, medium carbon steel, and high carbon steel. So low carbon steel is the carbon percentage up to 0.30% carbon, and from medium carbon steel 0.30 to 0.60% carbon, and high carbon steel from 0.60 to 1.70% of carbon. Now you know that basically steel is such type of element where this is the plain carbon steel. Now if you discuss on alloy steel, now alloy steel is such type of steel where it's basically defined a steel alloy to which elements other than carbon are added in a sufficient amount to produce an improvement in properties. That is called alloy steel. So alloy steel basically, if you can define a alloy steel, you can define like that. It's a one type of steel to which elements other than carbon are added in a sufficient amount to produce an improvement in a properties. The cheap alloying elements used in steel can be nickel, chromium, vanadium, tungsten, manganese, silicon, cobalt, and molybdenum. So these are the alloying element can be added in a particular alloy steel, or the particular one nickel, chromium, vanadium, all types of elements have some function on a particular steel. We can discuss on this type of topic, actually in the next class. So for thank you for today's class, for watching me and for listening me the class, and thank you very much. Goodbye.